All right, welcome to The Explainer. Today we are going to crack open one of React's most fundamental rules, the one that governs hooks. Now, it might seem a little restrictive at first, but trust me, by the end of this, you'll see it's the very foundation of what makes React so powerful. Let's dive in. So if you've spent, any real time with React, I am willing to bet you've seen this. You're coding along, everything's feeling good, you make what seems like a tiny change, and bam! Your whole app crashes with a message that's, well, let's just say it's not super helpful at first glance.
Yeah, this thing. This is the exact mystery we're going to solve today. And it's not just some random bug. It's basically React screaming at you that you've broken its one big, non-negotiable rule. And once you understand why that rule exists, this error is going to make perfect sense.
Okay, so to really get why this error happens, we first have to peek behind the curtain a little bit. We need to understand how React is actually, remembering the state of your components every time they re-render.
And you know what? It's actually surprisingly simple. For every single component you have on the screen, React just keeps a private little memory bank. Seriously, you can just think of it like a plain old JavaScript array. It's not magic. It's just a very, very organized list.
So here's how this actually works. On the very first render of your component, React builds this list. The first time it sees a useState call, it sticks that state into position 1. The first useEffect, okay, that goes in position 2. The next useState, you guessed it, position 3. And from that moment on, for every single render after that, React is expecting, no, it's demanding, to find those exact same hooks in that exact same order. Okay, so that's the theory, right? Nice and clean. Now let's see what happens when it all goes wrong. We're going to look at some code that seems perfectly innocent, but actually shatters this sacred order. All right, so here's a super common trap people fall into. We've got a component, and inside it, we're mapping over an array. But here's the catch. Instead of rendering a true component inside that map, we're calling a regular old JavaScript function. And that function just so happens to contain hooks. Since it's not a real component, all of its hooks just get dumped into the parent's memory list, creating one big, jumbled mess. And this is where the trouble really begins. Let's say on the first render, our array has 3 items. The parent component has its 1 hook, and each of our 3 function calls adds 2 more hooks. So 1 plus 6, that's a total of 7 hooks. React says, great, I'll remember that. But then on the next render, maybe the array only has 2 items. The parent hook is still number 1, but now we only make 2 function calls, which means we only call 5 hooks in total. Now, you gotta think about this from React's point of view. For React, this is a total disaster. It's going down its memory list from that first render. It checks off hooks 1 through 5, everything's fine. But then it looks at its list and says, whoa, wait a minute. I know there should be a useState value in slot 6 and a useEffect in slot 7, but where are they? You never called them. The order is broken, and React has no clue which state belongs to which hook anymore. This diagram, man, it just shows the chaos perfectly. We have one single cluttered memory array for that whole dashboard component. Render 1 fills it up nicely with 7 items. But on render 2, because our loop is shorter, we only call 5 hooks. Those last 2 memory slots that React was expecting, they're empty. It's a mismatch, and React has no choice but to throw its hands up and give you that error. Okay, so how do we fix this mess? How do we stop trying to cram everything into one confusing memory array and instead give each piece of our UI its own clean, predictable world?
Well, the answer is actually a prop you've probably used a million times, but maybe you didn't realize just how powerful it is. It's the key prop. And it's not just there to get rid of a warning in your console. It's the name tag that lets React identify a specific component instance and find its personal memory bank. So by taking that helper function and turning it into a real component and giving it that stable, unique key, we're basically giving React a crystal clear set of instructions. We're telling it, hey, React, this component right here, the one with key equals topic 1, it has its own state. If you see this key again on the next render, just pull up its old memory. And if you don't see this key anymore, well, you can just go ahead and throw its entire world away. And look at the result. This is a much better picture, right? Now our dashboard component has its own simple little world with just 1 memory slot. And each topic content component, well, it gets to be its own world, each with its own private, perfectly predictable 2-slot memory array. Now when a topic is removed, React just destroys its entire world. No mismatch, no confusion, no error. So at the end of the day, the whole game is about moving from the bad way on the left to the good way on the right. You stop trying to build one giant, fragile component and instead compose your UI out of smaller, independent components that each manage their own little world of state. That is the secret to a stable app.
Okay, so now that we have these nice, stable, individual component worlds, we can actually take this one step further and make things even more efficient. And that's where React.memo comes into play. It's just a simple wrapper you can put around your component, and it's like telling React, hey, before you bother re-rendering this thing, just do me a favor and do a quick check. If none of its props have changed since the last time, just don't. Skip the work and reuse the last thing you rendered. It's an incredibly simple way to prevent a ton of unnecessary work. Just look at the difference here. It's pretty stark. Without Memo, if the parent re-renders for any reason, all 10 of its children re-render too, even if absolutely nothing changed for 9 of them. That's just a lot of wasted CPU cycles. But with Memo, React is smart. It sees that only one child's props actually changed, so it only re-renders that one specific component.
I mean, in our example, that's a 90% reduction in wasted re-renders. That's not a small thing. This one simple change can have a massive impact on how performant and snappy your application feels, especially when you're dealing with long lists or really complex UIs.
So what have we learned? It turns out that whole rendered fewer hooks than expected error, it's not some cryptic bug. It's actually a guardrail. That strict rule about keeping hooks in the same order is the very thing that enables React's simple, predictable memory model to work at all. It's what makes stateful components possible. And that kind of leaves us with a final thought to chew on. What other strict rules that we run into in software aren't really limitations, but are actually the very things that enable the powerful features we love?